Thank you for joining us. In this video, we'll look at a couple of examples of using the remainder theorem. In the first example, it will be a one-step approach, essentially. We'll use it and then be able to get the answer quickly. And in the second example, we'll need to use the remainder theorem twice and then solve a system of equations. Okay, so for this first question, we have this function f of x, and we know when it's divided by x plus 2, the remainder is 3. Find the value of a. All right, so whenever it talks about remainders, we know we're thinking of the remainder theorem. So literally all we have to do is say, hey, if x plus 2 was a factor, what would be the root? And the root would be negative 2. So we know that if we evaluate f at negative 2, the value is going to be 3 because the remainder is 3 on division by x plus 2. All right, so x plus 2, I'm going to use negative 2 because if x plus 2 was a factor, negative 2 would be a root. But we know we have a remainder, so rather than equaling 0, we're going to equal 3, and that's going to be the same as negative 2 to the third power. All right, plus 3 times negative 2 squared minus a times negative 2 minus 5. We're simply going to evaluate. Okay, if we do that, negative 2 to the third power is negative 8, plus 3 times negative 2 squared, that's 3 times 4. Got a little ahead of myself there. So plus 3 times 4. And then minus a times negative 2, that's going to be plus 2a, and that's minus 5. So I know 3 has to equal all of that. So that means that 3 has to be equal to negative 8 plus 12, that's 4. Right, minus 5, that's negative 1. So negative 1 plus 2a. And so therefore we know that 2a is equal to 4, which implies a is equal to 2. So the value of a happens to be 2. Okay. If we look to our next example, we have this expression, this polynomial, divided by x minus 1, the remainder is negative 1. 1 divided by x minus 2, the remainder is 13. Determine the values of a and b. It's important to remember that this remainder theorem only works if I have polynomials for our purposes. So if I have division by x minus 1, the remainder is negative 1, that would be like saying, hey, f of 1 would be negative 1, and that would have to be a times 1 cubed plus b times 1 squared minus 4 times 1 plus 1. I also know that f of 2 on division by negative 2, my remainder is 13. And that would be a times 2 to the third power plus b times 2 to the second power minus 4 times 2 plus 1. All right, so if I expand this out, I have a plus b minus 4 plus 1 is minus 3. So a plus b minus 3 has to equal negative 1. And for what I have down here, a times 2 cubed, that's going to be 8a. This is going to be plus 4b. And then I have minus 8 plus 1, that's going to be minus 7, and that's going to equal 13. So now I have a system of equations that I can solve. My system of equations being a plus b is equal to, if I add 3 to each side, that's going to be 2. And 8a plus 4b, if I add 7, that's going to be 20. All right, so we have 8a plus 4b is 20. Now, let's rewrite and simplify this a little bit. So my lower equation, if I divide everything by 4, that's going to be 2a plus b is equal to 5. My upper equation, let's go ahead and leave that as a plus b is equal to 2. And then if I look at this and I take row 2 and I subtract row 1, the result that I'm going to have is going to be 2a minus a, that's going to be a, 5 minus 2, that's going to be 3 because b minus b is 0. So I get row 2 minus row 1 is a, and a is going to be equal to 3, and if a is equal to 3, then we know that b has to be equal to negative 1. All right, so we have a little system of equations that we need to solve, and after using that remainder theorem, we want to be able to solve that system of equations. Sometimes the system will be hard, sometimes the system will be a bit more straightforward as it was in this case. So once again, remainder theorem, I just need to substitute in what the root would be if I had a given factor, but I know that the remainder is going to be the value of the function evaluated at that particular possible root. All right? If that remainder is 0, then we know we have a factor. So using the remainder theorem, and if we have to use it twice, we might get a system of equations in 2 variables, and sometimes you might get to use it 3 times and have a system of equation in 3 variables. Thank you very much for your time.